There. Okay, excelente. Now, oh, you know what? I sure hope I got enough battery left in this. Let me see if I have batteries here. Hold on one second. Lithium. Good. I think that this is a brand new battery. I was trying to work on this yesterday, and the pen stopped working. Bad pen, bad. So I had to smack it around a little. No, I had to get this thing going here. Rayovac. No wonder why it stopped working. Those are cheap. All right. Plus at that end. Okay. All right. Give it a second to get registered. Oh, we're looking good. We are looking good. Oh, I got to lower the volume on that so it doesn't distract us during class. All right. Time to rock. Now, today's lesson is going to be very, very similar to yesterday's lesson. Somebody tell me something we got to reinforce and learn again today. Go ahead. Come on. Raise the hands. Let me know. Go ahead.
Function.
What about functions? Always look in the box. It'll always tell you every day when I ask this. Okay, what's one thing? Very good. Function uses input and output. What else we got? Come on. Raise hands. Read. Go ahead.
Identify the domain and range.
Very good. Well, guys, again, from yesterday, what is domain again? Everybody? Set of all inputs. Good. What's the range? Set of all the outputs. Nice. What's the third thing we're going to learn today? What's your name again?
Alex.
Alex, go ahead.
How to represent a function pictorially by role in a table as a set of ordered pairs and graphically.
Nice. Okay, what's the fourth thing we're going to learn today? Go ahead.
How to tell the function is linear.
Excellent. And the fifth thing. You already went. Somebody who hasn't gone yet. Come on, Milano, let's go.
How to look at a graph to tell input and output.
Very good. You must be wide awake right now. Are you awake? Or are you kind of sleepy? I suggest you look at your fingernail polish. It will wake you right the heck up. All right? All right, so here we go. A certain function, all I did today's lesson sheet, all I did was take yesterday's lesson sheet and change numbers. Okay? And what we're looking for us to do is to take a second day to understand this language. Remember, I told you a quick little anecdote yesterday. I said, look, if they dropped me in the middle of China and they wanted me to learn, I would have a very difficult time with that. Not because I'm not smart, but because I don't understand the language. And you guys are clearly smarter. You wouldn't be in the class. But if we don't speak the same language, if you don't understand what I'm saying, you can't get these questions right. So we want to go through and make sure this works itself out. Certain function takes all the numbers from -2 to 4 one at a time. These are called the? These are called the? That stunk. I don't care if it's first period. I hate. There's only 2 things in the morning I like waking up for. Fly fishing and photography. Doing math is not one of them, okay? But you got to will yourself past it. So, these are called? So sad. So sad. If the function in question multiplies each input by 1/2 and then adds 3, a corresponding output is created. Complete the table below for this function. Okay, so, projection mode. Good, okay. So if I take a -2 and I take half of -2, what's half of -2? -1. Then I add, what does it say, add 3? Add 3, what do I get? What is it? 2. Sweet. All right, what's half of -1? Everybody? -1/2. And then I add 3, what do I get? -2.5, which I can represent as -2.5 or -2 1/2. Either is acceptable. I like fractions. Most kids like decimals. Okay? My favorite. I love 0. Yes?
Yeah.
Oh, I'm sorry, positive. Yo muy malo. Okay, 2.5. Now, 0 is my favorite. I love 0. 0 is so cool. Oh, hold on a second. I almost forgot. can't believe you almost let me do this. We'll get right back to what we're doing there in just a moment. No, I did attendance.
Oh. Oh.
This is for Emma.
What did it say?
All right, come on.
There's something about like.
Come on. What is wrong with this website? All right, so here is highlight number 1. It blocked the plug-in. There's ways around this. Improvise, adapt, overcome, Heartbreak Ridge. Come on, Google Chrome. Let's go Google, dun 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 dun. Let's go Google, dun 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 dun. Come on! Do you know how old these laptops are? They're old enough that I bring mine. So, oh come on, would you please? It's just sitting there bouncing.
How is it sitting there if it's down?
This is a wise observation. It is bouncing. Still. Oh, the wheel of death. Oh, it is the wheel of death. It means something's about to go very wrong. Like I said, something is about to go very wrong. All right, yeah, whatever.
It doesn't want you to do this.
So sad.
Doing the Google that was there.
No, what we're going to do is finish the lesson, and then I'm going to, I think, take this piece and put it on my computer, and then everything will work perfectly. So we will make sure that as long as we have time during class, Emma is able to watch UNS Cespedes, Travis Darno, and Kelly Johnson hit home runs to win the game for the Mets yesterday. All right, so let's get this back in line here. Get those numbers back up before our little diversion there. Wheel of Death.
It's fun.
Oh, there we go. Okay, good. So, back to it. My favorite. 0. What's half of 0? 0 plus 3. 4, right? No, good. Okay. Excellent. Very good. Okay. Now, what's half of 1? A half. Plus 3. Oh, I mean, yeah, right. So that would be either 3.5 or 3 and 1/2. All right, next up, half of 2.
1.
Plus 3.
4.
4, sweet. All right, half of 3. 1.5 plus 3.
4.5.
4.5 or 4.5. Now you can see the pattern. 2, 2.5, 3, 3.5, 4, 4.5. Lastly, what's half of 4? Well, first off, if we follow the pattern and predict, the whole thing should work out to 5, right? So what's half of 4? Plus 3? Sweet. Okay, so that's the ability to fill out a table, and filling out a table is one way to represent a function. How do I find the domain? By looking at the table?
Sorry. Who's next?
That's not my fault. Yes? Is it Ivy?
Yeah.
Okay, what do you got?
All that.
All the X's, very good. Here's my domain. Excelente. And what's the range? Alex?
The Y.
Very good. All of the Y's.
All Y's.
Excellent, very good. Okay, so one way to represent a function is to represent it with a table, but that's not the only way to represent a function. We can also represent a function on, now you're being wise, we can always represent it on a graph. Okay, so the first thing we have to remember is which axis is which. We talked about this yesterday. X, Y. If you want to go like 5 in each direction, you can. If you don't label it on your paper, I do not mind. I'm not going to be upset. There's one time when you have to label the axes on your paper, and we did one of them at the very end of class yesterday. When the scale changes, like if I want this not to be 1 but to be 10, 20, 30, you have to write that. You can't just leave it blank. But if it's the typical 1, then it's not a big deal. Okay, so the first coordinate that we had there on our chart was -2, 2. -2, 2. The next one was -1, 2.5, then 0, 3, then 1, comma 3.5, 2, comma 4. I'm doing this right? Good. 3, comma 4.5, 4, comma 5, and that's as far as I went. And then I just do connect the dot, and there is my graph. Okay? Does that make sense, everybody? Okay. Now there's a lot of information involved in that graph that's not so obvious to me. For instance, anybody's parents here complain about taxes? When a politician stands up and starts saying into the microphone how they want to start new programs, that's code. They want your money. That's what it really means, okay? When I draw a graph, there's a lot of stuff in here, and some of it I don't come right out and say, but it is what it is. Isn't it true that any point on this graph is always x, y? Everybody agree? Okay, VP, are you with me here today? You look like you're about to fall asleep. You slept late all summer, didn't you? Yes, you did. It's time to get back to a little bit of a routine here. Now, X is associated with what? Input or output? Input, good. And Y with? Output, excellent. So I have input and I have output. And here is my graph. So I can look at any point on this graph. For instance, this point right here is the point 4, 5. And that tells me when the input is 4, the output is 5. When the input is 0, what is the output? 3. Excellent. So that information is contained in the graph. Now, it doesn't come right out and label every point as input, output, input, output, input, output. You need to be able to figure that out. Just like the politician just doesn't come up to you and say, "Ha, how are you? Vote for me, I want your money." They don't do that because are you going to vote for them? No, so he comes up and he says, "We need to come up with a new program. The poor people, they're suffering so bad. Can you vote for me and I'll solve the problem?" Yeah, right. When a politician comes up to you and wants to shake your hand and start a new program, cover your wallet. Just hold your wallet, don't let him grab, because that's what he's going for. Okay, now, there is the picture, the same exact thing as a table, and now we have represented it as a graph. But there are other ways to represent this. Can you take that information in your table and right now write a set of ordered pairs? Go ahead. Write it as a set of ordered pairs. Okay, so if we start writing this as a set of ordered pairs, there's a certain way that we have to present it. I'm looking on people's papers, and you're not writing it the way it should be presented. Okay, you're close, but not exactly. Do you know how, if you want something, there's one way to approach your mother and one way to approach your father? Right?
Yeah.
You know, like for instance, if you, like anybody here, well, Alex, how do you approach your mom if you want something?
There's a lot of ways to do that.
Okay, what about that?
Usually I just ask nicely. I try and wait for a time when he's not too angry at something else.
Okay, smart move. And to me, like, I had 2 sons. Be a man about it. Don't you dare try to suck up. If you're gonna try to be like, Daddy,
No.
I'm gonna be like, forget it. There's no chance you're getting this thing. But sometimes with Mom, you don't want to approach it the same exact way. You know, you might want to say, do the dishes first. Or maybe say, hey, Ma, need some help with the vacuuming? Perhaps you'd like me to rub your feet. Okay? There's, moms are big on that, all right? If you haven't tried it, you're going to get whatever you want the next time you do it. Oh, she asked you and you tell her no? Okay. So what happens is this. There's a certain way to approach Mom, a certain way to approach Dad, a certain way to approach your boss at work, okay? And they all need a little bit of fine tuning. When we're going to answer this question about how to express a function as a set of ordered pairs, notice the wording, as a set of ordered pairs. A set always begins with this notation. Every single time we ever write a set, that's always the first thing you write. That means the set begins. And then I write all the ordered pairs that I see you wrote on your paper. What was the first one here? -2, what, 1? 2. And then there was -2, -1, 2.5. Then there was 0, 3. Then there was 1, 3.5. Then it was 2, 4. 3, 4.5. And I think the last one was 4, 5, right?
Yeah.
And then I need to close the ordered pair set. So if I want to express it as a set of ordered pairs, I must begin here and I must end here. Okay? And then in between, I list them not vertically, but I list them horizontally. Okay? Any questions about that? Now, nobody got that question wrong because they don't understand it. People didn't understand exactly how to express things when they see those words as a set. And that's what I mean about us understanding a common language. If I said to you, express it as a graph, I want this. If I say express it as a set of ordered pairs, I want what I just showed you. If I say express it as a table, I want what we began with. All right? We can also express this as a picture. And that's what we're going to do here. Fill out the rest of the picture. Yes?
Do they have to be circles?
Ovals, boxes, whatever floats your boat. I like to allow student creativity. By the way, this is exactly the same thing as we did yesterday. So normally that'll never happen, but today it happens to be working that way. Okay, before we begin, or as you're finishing this up here, this oval on the left, this set on the left, what is that whole thing called? Go ahead. Very good. The guy on the left is called the domain. Now, you don't need to write that word when you draw the picture. I'm doing it just to make sure you understand what domain means. It's the set of all inputs. What is this guy on the right? Everybody?
The range.
The range. Very good. All right. So now, the next thing we need to do is we need to write down the elements. Notice that word elements. It means the guys in the domain. So I think we went from like -2 to 4. Or yeah, -2 to 4. So -2, -1, 0, 2, 3, 4. Now, what were the range elements that matched up with that? 2, 2.5, 3, 3.5, 4, 4.5, 5. And then we draw it this way. And there we go. Now, this is called, there's some terminology going on here. We have domain range. We have input, output. We have some other terminology that we use here, this terminology of the image. The image means the output associated with a particular input. So if I say to you, what is the image of -2? What do you think that is? Positive 2. -2 becomes what? Positive 2. What do you think the image of -1 is? Everybody? 2.5, right? Because -1 turns into 2.5 over here in the diagram. Next, what's the image of 0?
3.
3, very good. What's the image of 4? 5, very good. Now, in addition to the concept of image, see, just like you read left to right, and by the way, if you are Hebrew, if you're Jewish, you read Hebrew, and Hebrew actually reads right to left. It does. It doesn't go the way we do it, and they read from the back of the book to the front. So it's a little different. If you read Chinese, you don't go from left to right, you don't go from right to left, you go what? Top to bottom. So different languages read different things. Fortunately, for mathematical purposes, just like we read English left to right, we tend to read math what? Left to right. Generally speaking, the order of operations we have to be careful about, but for the most part it's here. So I would say, as I said before, the image of -2 is 2. But I could also look at this diagram, this is the regular function, and I could think of, well, what if I was to reverse the function? What if I asked the question like this? And this is a very popular question. Let's start with one way with a function. This is where we're leading to later in the year. What if I said that there's a function that defines how much money you make at work, or how much money you save from work, okay? Now, anybody here ever get something they really wanted to save up and buy? Okay, Hunter, what did you want to buy?
I wanted to buy a computer,
Okay, you want to buy a computer. Give me a guesstimate on how much that computer costs.
$700.
$700, okay. So we could create a function that says you get a job, and out of that money, you're not going to put it all in the bank, but you're going to put a chunk of it in the bank. So we might say that you start with $100 in the bank, and you add $50 a week. So our function would be y equals 50x plus 100, and that would be the function if I wanted to know how much I have after any given week. But I could also ask the question, how long until I get my computer? Right? Isn't that like one of those key questions? So I actually have to reverse it. See, to get to the computer, I would need 700 in this range on the right. And I would ask myself, well, what number here matched up with it? Because that's the one I really want to know, okay? Now, if I reverse it like that, that would be called an inverse function. What would it be called? Inverse. Inverse means opposite. For instance, what's the inverse of addition? Subtraction. What's the inverse of multiplication? Division. So in the same sense, the inverse means to go backwards. Now, if I say the image of -2 is 2, that's one way to say it. I could also say the pre-image of 2 is -2. Images go left to right. Pre-images go what? Right to left. So what's the pre-image of 3? 0, very good. What is the pre-image of 4? 2, good. Listen carefully, what's the image of 1? 3.5, right? Images, we go left to right. The image of 1 is 3.5. Pre-image, we go right to left. We go backwards because we are reversing or inversing it. The pre-image of 4 is 2. Does that make sense? Yeah. Okay, the next thing down here says we can take it and write it as a rule. That's another way to represent a function. Now, we just talked before about Hunter's dream for a computer, and we said, well, that would be y equals 50x plus 100, based on our model example. Now, what letter means input? What letter means output? X is input, y is output. So generally, where we want to express the output is, so y equals, my output is. Now, what do I do to the input in this problem? There's two things I do to it. What are they? Multiply by a half, and then what? Add 3. Which do you do first? Multiply by half. So I would say y equals 1/2 x plus 3. And that is to write the function as a rule. So far, we've seen it as a set of ordered pairs, we've seen it as a table, we've seen it as a graph, we've seen it as a rule, we've seen it as a picture. Those are the 5 ways to express a function. Okay? Any question about that? Okay. Now, if we come over here and just take a little further look at this, we realize that this matches up with the format of something we did a lot of studying of last year with Mr. Frank, namely, y equals what? Mx plus b. Good. What does m stand for? Slow. What does B stand for?
Y-intercept.
Y-intercept. Now, let me just pause for a second and explain this to you. I hated math when teachers would just tell me a bunch of isolated rules. Math is not a bunch of isolated rules. Unless the teacher doesn't understand where the rules came from. Then they're forced to give you just the rules. If, on the other hand, you understand that mathematics is brilliant, and, see, you're not going to like the brilliant part because that makes it sound really hard, but this is the part you're going to like. Mathematicians are super lazy. Right? Is that sounding good? Okay. Mathematicians want to take the most amount of work possible. You're going to get me to yawn. They want to take the most amount of work possible and put it in the shortest possible way to do things. So, is that a less than or a greater than symbol? Anybody ever get confused? You kind of second guess yourself? I used to do that all the time. And then the teacher gives you this absolutely idiotic rule about the alligator. Right? You remember that?
Yeah.
I'm like, are you serious? The alligator. Hold it. Watch this. Ready? See this? This is a number line. That's the less end of the number line. That's less than. Greater end of the number line. That's greater than. All right. We just about finished everything we need to do. Get ready for tomorrow. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Homework's the word in the paper forward. It's the same every single night. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos. Amigas. I had a dog named Gizmo.
I do.
It's my favorite.
You do now? There you go. Hasta la vista. You be awake from now on. All right. Have fun. Enjoy.
Samantha says hi.
Tell her I said hello. Have fun, guys.
So does
Someone forgot
Ashley.
their binder.
Excellent. Tell them all I said hello.
Okay.
Someone forgot
Are they
their...
still playing soccer?
No,
They
she's
might
in
be
college.
James.
Sam's in college.
Yeah, Samantha and Ashley got a job for the hotel in the city.
It's Nate's.
Okay, what hotel?
It's the Indigo.
All right. I was just at an Indigo in Riverhead a couple of weeks ago.